f prime squared dx over the time. So the distance of the formula. This is actually the average speed, right? This is average speed. I should put it like this here. Average speed. The instantaneous speed would be what? Remember how we did it in chapter 2. We divided each of the quantities into average, instantaneous, average, instantaneous. Average speed is the arc length divided by time. Instantaneous would be, well, that would be the magnitude. It's better to always express it as the magnitude of the v vector, the instantaneous v vector. So let's just draw it as like that. The magnitude of the instantaneous v vector. And then when we go to the v vector, then we'll see what the v vector is. Okay, velocity vector is also, we can divide it into two. Average velocity is going to be the displacement divided by time. Okay, and then average instantaneous velocity is going to be the derivative of the x and y position as a function of time. So x prime of t I hat plus y prime of t j hat. So the velocity, because this is a two-dimensional situation, the x is changing as a function of time and the y is changing as a function of time, right? So x prime of t I hat plus y prime of t j hat. And then the acceleration, that one also has two. Average acceleration is v final minus v initial over t. And then the instantaneous acceleration is going to be x double prime t I hat plus y double prime t j hat, which is the derivative of the velocity. V prime of t, Vx prime of t. In other words, the derivative of the x component of the velocity plus the derivative of the y component of the velocity, j hat. So there's the average acceleration, there's the instantaneous acceleration. You could write this in a more detailed form as, we could write this like this: v final x minus v initial x I hat plus v final y minus v initial y, the j hat, divided by t. So this breaks down into this, and then this one breaks down into this. So the derivative of the x component of the velocity and the derivative of the y component of the velocity. So this is basically very similar to the chapter 2, except we expanded it to two-dimensional analysis. Okay, let's do one good example that will utilize all this stuff.